Alright, in this video we are going to go over SI prefixes, the ones that we're going to need for this electronics unit. And then we're going to go through some Ohm's law practice, which we did the other day, using these SI prefixes. So to get started, let's actually copy down this table. This is what you're going to need to do all your conversions. It's up on the wall, but if you're sitting in the back, it might be kind of hard to see. So let's just go over the prefix that we are going to use. We're not using all of them. Really in electronics, we're just going to use the ones that are multiples of 3. So it should make things a little bit easier for us. So let's start with the biggest one that we are going to use. And you might have heard of this when you're talking about computers or flash drives, but it is giga, like a gigabyte. So giga, G-I-G-A. Symbol for that is a capital G. Important that is a capital G there. And the factor is times 10 to the 9th power. So like I said, we're always going to be dealing with powers of 3. So this is the largest power of 3 we're going to be dealing with, 10 to the 9th. And if we actually write that out, that's a 1 with 9 zeros. 3, 6, 7, 8, 9. So if you have 1 giga anything, you have 1 billion of that. Okay, so that's the first one. Now we're going to go down to the next biggest one, which is mega. M-E-G-A. Prefix for this one, didn't get too creative with it, just a capital M. And again, we're going down in powers of 3, so this is going to be 10 to the power of 6. And if we're writing this out, again, a 1, but now we have 6 zeros. So mega, maybe you've heard megabyte before with a computer or a hard drive again. Probably not hard drive nowadays, and megabyte would not be very much. But it is 1 million bytes. We're talking about a megabyte. Mega anything is million. And then the last big prefix that we're going to use is kilo, which you probably heard a lot more. This one's used quite often. Kilogram, kilometer. Now, the weird thing about kilo is that it's not a capital K, so it is a lowercase k. So these are capital M and capital G, but for kilo, it is lowercase k. And then, again, we're going down in powers of 3, so this is 10 to the power of 3. And you guys know kilo is just 1,000, or 1 with 3 zeros. Okay, so let's go ahead and go down to the smaller side. So if we're going smaller side, the first one that we're going to be looking at is milli, M-I-L-L-I, which is a prefix of lowercase m. So notice the case is important. So lowercase m is milli, that's times 10 to the negative 3. If you had an uppercase m, that's a mega, that's 10 to the positive 6. So you got to pay attention to the capitalization there. And if we're writing this out, this is 0.001. So if we're looking at this, it looks a little bit different. Remember where your decimal place starts. So decimal place for the larger values starts right here. So if we're going up 3, 1, 2, 3, that's how we get to the positive 3. Whereas on the opposite side with the negative 3, we have to go 1, 2, 3. So there's only 2 zeros here. So we have to get to the other side of that number to get to negative 3. And that's going to be the same when we go on to our next small prefix, which is micro. So micro, M-I-C-R-O. This is a Greek letter mu. So it's kind of like a U, kind of like an M, but it's got these curves on it. So it's like a U with an extra little curve on it. It's mu. And that is going to be times 10 to the negative 6th power. If we're looking at the numeric value, again, we have 0.1, 2, 3, 4, 5, and 6, negative 6. All right, the last prefix that we're going to be using in this class is going to be nano. And again, the symbol for this is a lowercase letter, it's a lowercase n. And we're going in powers of 3, so this is going to be times 10 to the negative 9th power. If we're looking at numeric values, this is 0.1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so those are the values that we're going to be using, the prefixes we're going to be using. So let's go ahead and actually do some practice to see how this is done. Okay, so the first example we have here is 1,700 ohms, and we're trying to write that in a neater way. So the decimal place for this one starts right here. We're going to be going back 1, 2, and 3. So if we're going back 3, if we're going to the left and we're converting from a standard unit to a prefix, that means that we're going to be using positive exponents. So in this case here, we moved it back 3, so the new decimal place is 1.7. But because we moved it back 1, 2, 3, we need to say that this is times 10 to the power of 3. And then we can look at our table, and using our table, we know that 10 to the power of 3 is kilo. So 1,700 ohms is equal to 1.7 kilo ohms. All right, so there's one example there. So again, in this example here, when we're converting from standard to the prefix, we need to realize that if we're going to the left, it's positive. Okay, well, this next example, we're not going to be going to the left. We're going to be moving this decimal place 1, 2, 3 to the right. So again, if it's standard to prefix, this time if we're going right, it's going to be negative. So in this case here, we moved it 1, 2, 3 to the right to get 4.0, or just 4. And that's times 10 to the negative 3, again, because we moved to the left. So in this case here, 10 to the negative 3 would be milli. So this would be 4 milliamps. And it should make sense. This looks like a small number, so we're using one of the small prefixes. This looks like a big number, so we're using one of the big prefixes. This is positive, this is negative. Those things should just kind of check out. Okay, so let's go ahead and try a big one here. Again, this one we're going 1, 2, 3, 4, 5, 6 to get to a single digit here. So if we're going 6, that's 1.15. Again, we're going left here, so left is going to be positive, times 10 to the 6th. Go up to your table, you see that 10 to the 6th is mega. So this is 1.15 mega, capital M, make sure that's capital M, volts. Okay. This one's a little bit weird because it's already written in this scientific notation for us, but sometimes maybe you'll get an answer in your calculator that looks something like this, and we don't have a prefix 4 times 10 to the negative 4. So I'm going to write this out, but I think once you see me write it out, you'll be able to kind of figure out ways to do this without writing it out all the way. So if we're writing this out, we actually do it in reverse. So 34 times 10 to the negative 4 is 0.12, and then 34. Now, if you want to check that, you can see it's 1, 2, 3, 4. So that's 34 times 10 to the negative 4. Okay, now that is something that I would not want to write out because 0.0034 amps, that's not something that's meaningful to me. I need to use a prefix. So what I can do is just check and see. So if I actually go back and I try this again now that I've written it out, we have go 1, 2, 3 to the right. So that's going to be 3.4. And then because I went to the right, I'm going times 10 to the negative 3. So notice when I took my decimal from here to here, all I had to do was just decrease this to, or actually, sorry, increase this to negative 3. And now I can write this as 3.4, 10 to the negative 3, which is kilo, so 3.4 kilo, and then amps. Okay, so you can do that for sure. You can definitely move to the left if you want to move to the right to get these to a base of a 3 so that you can use the prefix. That's what you'll have to do. Okay, so we can go ahead and try one more of these type of problems. So you see this one, if we go all the way to the end here, so we all go to the 5, then that's going to be to the negative 4. So if we just go 1, 2, 3, that gives us 0.5, which is fine. But that's times 10 to the negative 3. We know that there is a prefix. So instead of going and then having to undo it, we can just notice that up front that this is just times 10, 0.5 times 10 to the negative 3, which we know is 0.5 milliohms. And I just realized here that in my previous problem, I made this mistake. This should not be kilo. Definitely should not be kilo here. This should be milliamps. So make sure you fix that in your notes there, milliamps. Okay, so I'm going to let you try these practice problems here. So go ahead and pause the Edpuzzle to try these on your own, and then you'll put your answers in, check if you got them right. But now we're going to move on to the actual Ohm's law practice with this, and you're going to see the kind of the steps that you have to do to be able to do both of these things where you're using Ohm's law and you're using these prefixes. So let's go ahead and take a look at this first example. So this says a circuit's connected to a 5 kilovolt power supply, has a resistance of 10 mega ohms. How much current will be flowing through the circuit? So first thing we need to do is we need to figure out, okay, well, what's going to be our formula that we're going to use? So remember, we have the trusty Ohm's law triangle. V is in the top, I and R are in the bottom. In this case, if we're looking for current, we're going to cover this up. So we got V divided by R. So we know that that's going to be the equation that we need to use. Now the second thing we need to do is we need to figure out what are these prefixes, and we need to actually write them out. So in this case, if we have 5 kilovolts, that's going to be what's on top of this equation here. This is 5 times 10 to the third volts. And then we're going to divide that by, so 10 mega ohms is 10 times 10 mega on our chart is 6. So that's 6 ohms. Okay, now, you guys have been doing exponents in your math class, so I think you can do this part of the problem pretty easily here. 5 divided by 10, if you want to use your calculator to do that, you're going to get 0.5. But that's what we're going to do. So you're going to take kind of your two parts. You're going to take your numbers, and then you're going to take your prefix, and you're going to do the math separately, and then you're going to put it together at the end. So 5 divided by 10 is 0.5. And then 10 to the third divided by 10 to the 6th. Well, remember, 10 to the third divided by 10 to the 6th. So you have to subtract these exponents if we're dividing. So this would give us 3 minus 6, which is negative 3. So 10 to the negative 3. So this is 0.5 times 10 to the negative 3. Now, if we're looking at that 0.5 times 10 to the negative 3, we know that that is milliamps, right? Milli is what we're talking about here. So if we were writing this out, this would be 0.5 milli, and then again, we're solving for current, so the unit is amps. Okay. So that kind of made sense there. Again, you have to know your exponent rules. So if we're dividing, you're subtracting. If you're dividing this, you can just do that in your calculator. Let's go ahead and try another one. Okay, so for example 2 here, we have, we're trying to figure out the resistance. So again, going back to the triangle, VIR, we're looking for resistance this time. So we're going to cancel this. So it's going to be voltage divided by our current. So we've got 120 volts. Now, we didn't talk about this, but one of your base units, your standard unit, if you don't have a prefix, is just times 1. Well, if we're talking about exponents, we have 120 times, now if we want to write it in terms of times 10, because that's how we're going to have to do the math, 1, if you remember from exponents again, is just 10 or anything to the 0 power. So that is the voltage that we have, and we have to divide by the current. So this is 50 milliamps. So 50 times 10 is to the negative 3 amps. So if we do this here, you have 0. Well, so let's do the 120 divided by 50 first. If you do 120 divided by 50, you can use your calculator for that. That's just 2.4. But then we have 0 minus a negative 3. Well, you know if you're subtracting a negative, you're actually adding. So this is times 10 to the positive 3. Remember the unit that we're using for resistance is ohms. And so we're going to use our prefixes times 10 to the third, that's kilo. So this would be 2.4 kilo ohms. Okay, so let's go ahead and try one more example before you do some practice on your own. In this case here, we're looking for the voltage present. So again, going back to the trusty triangle, V, I, and R. In this case, we're solving for V. So we have I multiplied by R. So we're going to have to use a different exponent rule, but the process is still the same. So first thing we're going to do is write out what we're going to be multiplying. So we have 100, and then this is going to be times 10 to the 0, because it's just the times 100 by itself, ohms. And we're going to be multiplying that by this 55 times 10. This is our mu, that Greek letter mu. That is standing for micro, so that's times 10 to the negative 6th. Okay, so again, same process here. We're going to multiply our numbers, so that's going to give us 55 and then 100, 0, 0. And then this time, because we're multiplying, we have to add the exponents on these 10s. So 10 to the 0 times 10 to the negative 6th is going to be times 10 to the negative 6, because 0 plus negative 6 is just negative 6. Now, if I'm looking at this, this is not finalized yet because it's 5,500 times 10 to the negative 6. I can make this better. I can take some of these zeros off. So if I move this decimal place 1, 2, 3 to the left, then what I can do is I can actually increase this from negative 6 to negative 3. We're getting closer to 0. So this is the same thing as 5.5 times 10 to the negative 3. And if we're then using this, this is much easier to see, 5.5 milli, and again, we're talking about voltage here, so millivolts would be the final answer. Okay, so once you finish these notes here, then you're going to go ahead and get the practice from Mr. M, and once you've done this practice, hopefully you get this all correct on the first time, you show Mr. M, he'll check it, and then you will have the homework. Good luck, have fun, Ohm's Law.